passes that were dropped yesterday, our guys would have normally have caught. If they would have caught just 2 of those passes, I think we would have won the game. I don't know if any of you are watching that.
Yeah.
They never missed, and they missed a couple of passes for first downs, and that was it. That's all it was, 2 passes. Anyway, we can debate that later.
Or maybe just run it, not kick it.
Everybody has opinions on it. All right, so this exercise, we're going to, I got the Word document open, I guess I'll do what I usually do. Here's the D2L page. For 1B, all that's here is a Word document, so there's no more data to download or anything. You already will have all the data created that we need so far from the previous one. This is one of those documents where, well, like all of them, you could read the steps, do every step it tells you, and have it exactly work correctly. And it'll be, when it's done, it'll be perfect. Nothing will be wrong. But there's a lot of little things going on that aren't explained in great detail in the document. So again, that's why I like to demonstrate this, because I want to say why we're doing some of these things, all right? So first off, it does say, open up the Class A assembly, Class A surface assembly that we made. And I open it, and I'm just gonna remind you of something. I might have said this before. I don't know if I said this much about it, but I open up the assembly, and you can kind of tell on my screen, this stuff doesn't look very smooth. It's kind of faceted, right? Well, the reason is, it's not fully loaded. I know I talked about this before, I don't remember if I talked about how it looks on the screen. They're not fully loaded when I opened up the assembly. It didn't fully load those 3 parts. It brought them in, but they're not fully loaded. I remember saying this last time. If you go to File, Assembly Load Options, basically this says, when you load an assembly, it's gonna load all the parts, but mine does a minimal load. It didn't really fully load the parts. You could fully load them. I think I talked about that. It doesn't really matter so much, but if you're wondering why is it choppy like that, that's why, because they're not fully loaded. There's no square around these red check marks, right? Remember that you could formally go to either any one of them and say, well, let's open that fully. I didn't do it, but you could do that. You don't even really have to do that, because when it comes time to activate one of them, like, I don't know, just double click, make it the work part, that fully loads it. So once you do it, there's a square there. Now, of course, that still doesn't look smooth, but that's not the part I'm seeing. What I see right there, actually, it's probably both of those parts. Actually, now, that's my outputs, right? If I double click on that to fully load it, see, it's a lot smoother. It's still not perfectly smooth, but it's smoother than it was. That depends on the resolution on the screen and whatnot, but it's now fully loaded. So in case you're wondering why it may have looked choppy, it might not have been fully loaded. Now, then again, yours might have the assembly load option where it's already fully loading everything. So that's really nothing to do with today's project, but it just, because it comes up, I like to show that stuff. So anyway, it says open up the assembly, right? And what we're gonna do here, the first part of the exercise, the first half of it, just about, is remember we made this data, we pretended we were Class A design people, and we came up with this data from, coming off the clay modeling, and all the executives said, yeah, that's good, that's nice and clean and smooth. And then as the body side people, I'm gonna open my body side. We made another assembly called body side. So that's a different group of people that's also working on this project. That we borrowed the data from the Class A people. So here, if I show let me hide my body side stuff. Right now, all I see is my inputs as the body side person. Okay, I got a bunch of stuff hidden, I'll just show it. So here's the stuff that I borrowed as the body side person. I borrowed that from the Class A people. All right. So it's the same stuff I just saw. Here's the Class A. Here's what I borrowed from them, which looks the same. But what we're doing in the first part of this is, a change came along. We don't have it exactly right. The Class A people, maybe somebody told them, hey, you're not supposed to give them trimmed up stuff like this. You're supposed to give them a nice big clean slab surface, right? This is trim, that's a trim shape that it's got, it's flat on the top, along the back, but then there's a small flat there, and then it's got this big curve shape by the fender flares out, or the wheel well, and all that stuff's back there. Well, That's not really the root geometry. In NX, like most CAD software, not that you need to know this, but most CAD software, every slab surface, every root surface, it's really just got two directions. So it's usually four sides. There's a U direction and a V direction. So it's usually, you know, four-sided, not multiple sides. Or sometimes it's three-sided. It can work with a triangular shape too. But this is not really a root slab surface. That's not a rectangular slab, okay? So somebody must have made a rectangular slab, and the Class A people would have done that. They would have maybe scanned the model, and then made a surface through the scan points, and then made a nice big clean slab surface that matched it, so that they wouldn't have trimmed it like that. Whoever made this exercise a long time ago, I took this class over many years ago from somebody else, who actually did this at Chrysler. They worked on upper body stuff, and they came up with that piece. But we've decided now as the Class A people, you know what, we shouldn't give them that. We should have gave them a slab. So that's the first part of the exercise, all right? So it says, activate the Class A surface part. Right? And it says hide the outputs, because we see them both, right? I don't know if you remember this, but last week, we took our Class A stuff, and we said, well, all the people that are gonna borrow our information, we want them to go to one folder. We want them to go to this outputs. It actually is a part, but we're treating it like a folder. So we put this stuff in that, right, in there. So in the Class A I have, all this stuff. A fuel door body side, a fuel door, cut line fuel door, a center line of fuel door opening, I got all that stuff. Okay, well, in the outputs, I got the same stuff, but links to it. So we're linked to all that other data, and there's more to it that I just wasn't showing. So here is where we build the stuff as the Class A people. Then we take that and stick it in our outputs folder. So going back to what I said, we decided, you know what, we weren't supposed to give them that trim piece. We were supposed to give them the nice, clean, four-sided rectangular slab. Okay, so it also does this. It says go to Assemblies, go to Associativity Manager, and it doesn't really explain why here, but it says if this isn't checked, put a check mark here. Delay geometry, expression, and PMI updates. I might have mentioned that one before too. It's a more common way of working, because we're gonna be working with links, right? And we're gonna change the links in the other part, or the links in the other part are gonna be affected by what we're doing here. The other part has links to this part, okay? When you make changes, sometimes you want everything to automatically change, but a lot of times you don't. Because maybe you don't want everything to change all at once, because sometimes that causes errors. So you might wanna update little pieces that are new as time goes by. I'm not doing anything, I'm just trying to convince you of this. So it's a good habit to delay the updates, the one called geometry, expression, and PMI updates, right? So if yours isn't checked, it tells you to do that in the book. And then it's kind of ignores that. Later on, that'll come back, okay? Then it says, in the part navigator, we got this guy called, look at it here, part navigator, oh, it's under form, I'm sorry. It says, locate the body side main slab, it's that guy. I had it hidden in mine for some reason, but there it is, all right? We wanna make it the current feature. Because what we're gonna do is we're gonna take that, and there's a tool in NX that lets you make the original root slab from this. This is trimmed. Root slabs, like I said, they're usually four-sided. Well, there's a cool operator in NX. There's also one almost identical in CATIA. It says, well, if there was a root slab for this, what would it look like, right? Well, I wanna put it in the tree. I wanna create it, and I want it in the tree right after this one. So I'm gonna make that the current feature. So it becomes bold. That's just saying, well, that feature group is now active because you're working inside of it. So whatever I create next is gonna go right after this. And in the Surface tab, okay, there's a group over here called Combine. By the way, if you go to the Surface tab and you don't have all these groups, as a reminder, maybe you're not in the advanced role. Remember the roles down here, the little hammer and wrench. In your content, there's an advanced role. I don't wanna click on it because I customized it a little bit, and that'll undo my customization. But if you don't see a lot of the tools up there, you might be in the wrong role. Or, there is a way to add these. All right, so here's the ribbon. Again, this is nothing new to the project, but I know this came up a few times. along the ribbon, I've got all these tools, well, they're in groups, and at the end of the ribbon, there's this little pull down, okay? If there's a check mark here, then that group is visible. Mine are all visible. But you might have like a combined group, if I click on this, it unchecks it, so it's not up here. It's just hidden, it's still available, but it's hidden in the ribbon. So if you don't see the combined group, maybe go to this little pull down way on the right, click on it, and there probably isn't a check mark next to combined. Okay. So we need that one. Why do we need that one? Because we're gonna do the roof surface, the roof slab, right? So it says, in the combined group, in the more gallery, there's this thing called untrim. Untrim is another way of saying, give me the slab that made that originally, okay? It says select face, and you can pick multiple faces. This feature called body side main slab, it just happens to be just one face. So it really doesn't matter what I have this set at. Mine's at tangent faces. It picked all the faces, which is only one, and all you do is hit OK. And there's the untrimmed original slab, okay? Well, that's what it would have looked like. If this was made correctly, I should say correctly, if it was made the way, you know, if they would have thought of this beforehand, they would have first made that slab, like I said, from scan points or whatever, and then made a nice smooth surface through it. And then they would have trimmed it to make the yellow one, okay? Well, right now the history is kind of backwards. The untrimmed came from that. So in other words, I have to keep that original one, because it's a parent now of the untrimmed one, which seems backwards, but that's just the way it worked. But anyway, it came right after the tree, all right? Well, another thing is, I want all the people downstream, we gave them something called the body side main slab, but it's the yellow one. Well, I want this to be the body side main slab, okay? So I want to name it that, but then this one's already named body side main slab. Well, we're going to change the name of that one, and then we're going to give this one the correct name. So it kind of tells you that. I don't think the order really matters too much, but it does say, well, the order, it tells you to go to this one, you go to rename, to change the name. We don't want it to be called body side main slab, we want it to be called body side trim slab, right? And ultimately, we're not gonna use it anymore, but we have to keep it, because our untrimmed slab is relying on it, okay? So that's called body side trim slab. If you recall, we, when we're doing links, I keep talking about it, it's like a pain, it's, what's the word I'm looking for? It's busy work, but there's a word I can't think of it right now. It's something that has to be done. We want to rename the sheet body behind it, right? That's the feature with a name. We want to rename the sheet body. Maybe I'll hide the untrim for a second. If I hover over it, go to properties. Oh, I didn't pick it right. Wait for the 3 dots. Right click on the sheet body called body side main slab. It is already named. If you see uppercase there, that means it's named, but we gotta change that name because we named that before, but now it's the wrong name. So we go to properties, and I should have copied when I typed it in up there before, but I didn't. So we're gonna call this trim slab. And remember this, the sheet body itself, even if you type it in lowercase, it's gonna make it uppercase, all right? One thing I noticed, I was showing this to someone earlier, and they don't have the apply to work part button on theirs, and I do. It doesn't matter, but I don't know why. There might be a setting somewhere, or maybe you've got a slightly different version of NX2212, because there's different patches they put on there, maybe, I don't know. But in the instructions it says, check the box called apply to work part. If you don't see that, don't worry about it. Okay, it's not gonna hurt the exercise. Anyway, so I renamed the feature, called that trim slab, because from now on, that's what I want that to be called. I also renamed the sheet body behind it. There you can see now it's body side trim slab in all uppercase. Okay. The reason I did that is because really, this one is the one we gotta name, and this is the one we're gonna use. I'll show it again. This is the one that's gonna be what I really should have originally made as the body side main slab. Okay, let me make sure I'm doing the same order I'm telling you. Yeah, so it's gonna be called body side main slab. Now out here, if you do it uppercase or lowercase, it's gonna stay that way. Not that I don't care, but it will remain, it's not gonna make everything uppercase. So I renamed the feature, but because we're gonna involve it with links, the naming of the sheet bodies makes linking a lot easier, or better, because you see the names. So I wait for the three dots, select it, go to the sheet body. This is a new sheet body, it does not yet have a name. It says sheet body of, but it doesn't say a sheet body with a name right after it. So we go to properties, and again, I forgot to copy that, I should have. Copied the text when I did it in a feature, and then I could have just pasted it right here. And because I do have the box, I'll hit it, apply the work part. And that sheet body should also, have just gotten a name. Like that, uppercase. If you see the uppercase, then the sheet body has a name. Alright, so kind of busy work, that's what I was trying, well, that wasn't really busy work, but there's another word I was looking for. Tedious work, that's what it was. It's just tedious work, naming things, right? But we do need to do it. So then it says, right, now that I've done that I did this in the work part, I'm also gonna update to the end, well, they don't call it that anymore, now they call it make last feature current, okay? Then it says to save it, this time it does say save the work part. So I'm implying, just go up here and just hit this save, okay? Because I am actively inside of just one part in the assembly, and that's all I modified, and I did make a change, so I did save it, all right? Now, in the picture, they're showing that, that guy too, and all the guys. Well, I guess I found. But then it says, all right, now if we go to the assembly and go to the Class A outputs, remember, last week, we would have taken everything we did in the Class A and linked it to the outputs, okay? Yeah. I'm looking at mine. Okay, I'm on, there's a step in the book and one person didn't do this. So, see right here, this is the downstream file, this is the outputs file I'm in. And it does right here say, this is now called body side trim slab. Okay, see the name of it there? And it is highlighting already. Okay. However, some of your machines, I know I just saw it on one, it might not rename it, okay? If it doesn't rename it, don't worry about it, because what I'm saying is, remember, this is the folder where we're putting stuff for our downstream users. Well, this is what I told them to pick before, body side trim slab, even though it wasn't called that. It picked up the new name. But I still want to change it because I don't want them to use that one anymore. I want them to use the new one that I changed the name to body side main slab, okay? So this link is pointing to the wrong thing. So we're gonna change it. There's a real manual way to change it. Right. Double click on it. One called body side trim slab. If you double click, it's showing you how you made it before. It's kind of saying, well, you picked a certain body, made a link to a certain body, and it's highlighted. Yep, that's the one I linked to, the trimmed one. Okay, I don't want that one anymore. I want the new one. Now, one thing, just be aware, it doesn't replace what's already picked. If I pick this one, now it says there's two things. Well, we don't want that. I don't want one link to be pointing to two separate bodies that are right on top of each other. I want, the right way to do it is unselect the first one. So when that field is highlighted, remember this, my favorite button, deselect all. Now nothing's picked, but if I pick this one now, just that one, actually let me unpick it again. Just to remind you, here's why we name things. See, if I hover over that, that name jumps right out at you, you're right on the correct one. Because sometimes things are close to each other and you might not be on the right one, right? Depending on what your cursor's on top of, you don't always get the one you want right away. So that's a good way of knowing. I mean, that's one reason we renamed sheet body, because it tells you right there. If it wasn't renamed, it would just say it was a sheet of some feature in another part. If I see the name, I'll pick it, and I'll hit OK. And this is just saying it made that feature group active. But there it is. So now it's got the correct name, okay, and it's the correct full slab. So that's the first part of the exercise. Well, that's part of the first part of the exercise. We did this now, we basically fixed this as the Class A person, okay? And I am gonna save the whole Class A assembly, so the fast way to save that, just in case, you know, I made changes in all these, I know I said this before too, if you make the top of the tree the work part, and you hit this, or File, Save, Save, they both say the same thing, it saves the work part and any modified components. That's the work part, what's the component, any children. So this will save everything that needs to be saved, starting here, if I hit this guy, alright? So, I did that. So now, my work as the, Class A person is kinda done. Now I'm gonna put on my other hat, I'm gonna go to the body side. So it says open up the body sides assembly, which we would have made last week. Alright, I wanna go back here. Okay. And there was an inputs, and then a working file, and then the outputs. We didn't put anything in the outputs, cause we could assume someone else is gonna come and borrow our data later, but we're not doing that in this project. So if I go to the inputs, make it the work part, all the links are broken right now, but they were broken last week when we, because this part doesn't see the other part. This is where I brought in the data from Class A person, from their output file. It doesn't see it right now. So they're broken links. That's okay, that's a normal way of working. I know I say that a few times too. Typically you do work with broken links. At some point we're gonna say, well, I wonder if they changed that other stuff, so we'll reconnect it to see. At this point, we're saying, oh, I don't know, I don't see it. Right? Well, we actually know that they made changes because I just made the changes as the Class A person. Okay. So, to see the changes, we'll go back here. The output Class A is where the changes are. To see it in my assembly here, I need to add that part to this assembly. I have the outputs on my body side, but the data we're going to get our stuff from is the outputs of the Class A. So, in this assembly body side, I'm gonna go to the Assemblies tab. Add component is how you add an existing part, not a new part, okay? In my window, I see loaded parts. You may or may not see that. And I do have it loaded, so it's right there, outputs Class A. But if you didn't see it, if you don't see that loaded parts for some reason, you could say, well, let me go find it. Let me go find the one I want. You'd have to go to the right folder, and it would. I have a folder called Class A Assembly, and there it is right there, outputs Class A surface. Okay. So I wanna place that one. I'm just putting it in my assembly. It says, just so you don't get all kinds of messages about lining it up, if you set this to absolute, in my instructions it says, in the add component dialog, use absolute work part for the location and entire part for the reference set. So right here, make sure that says absolute work part. That means it's just gonna place it right at 0, 0, 0. You don't have to worry about positioning it, because that would be extra steps. And then down at the bottom under settings, there's a reference set called entire part. It says use that, because it could be under model or empty. And it brought it. Now we only temporarily brought that in. There's the outputs from the Class A. And I in fact see that, yeah, they did change something there, right? My inputs has that trim sheet. The outputs that we're pointing to doesn't have the trim sheet. Well, even here, it doesn't automatically relink the stuff, okay? That's on purpose, basically, because you don't always want to just, well, if there's new stuff in the file, replace everything right away. Well, you don't necessarily want that, right? So we have to tell it, yeah, you know what? We were pointing to that, but we also wanted to know that if they change anything there, we want to pick up those changes. So what we do is, while that's loaded, we've got this tool that it's gonna be a little confusing. This is probably the trickiest part of the exercise, okay? And it may or may not work for everybody. But it's called a wave relinker, or it used to be called general relinker, now it's called wave relinker, right? And if I hover over it, see it says it's a name matched part and object. It searches for linked features or linked expressions, but looking for names, okay? So even though that part, my inputs, remember my inputs was pointing at this other outputs file. And we kind of see it right now, but I have to tell it, look through their outputs and see what's different, and look for the stuff with the same name as we had. You know, let me do this real fast. If I go to my inputs and I look at what I had, here's what I was pointing to. I was pointing to that stuff in the other person's file, and that's what those are the names I use. C-line, a fuel door, body side, main stem, all that stuff, right? So that's the name it's looking for. I don't think it matters what's the work part here. Basically, I'm gonna tell it, everything in my part here, that's got the same name as everything in there, point to the new stuff. Okay? So I'll show you. Yeah. It's very logical. I don't expect you to feel like you're an expert at this now right now, but it's your first play with this. So here's what it looks like, kind of complicated. For the source and the target, like where are we looking for the stuff that's been changed, and where did we put it in our file, right? The source is where we get it from. The target is which one of ours has the inputs. Now, there's other ways to do it, but a way to control it the most is say, let me select the part that I'm gonna call the source, and let me select the part that I'm gonna call the target. So they both are unselected parts. The source, where we get it from, it's the outputs. It's their stuff. They're the one that gave us this data, that's the source. The target is my inputs. That's the one that was looking at theirs. I wanna make sure, well, we point to all the stuff that's got the same name, okay? Now, as far as the name, it does tell you this in the instructions, I think. Let's see if it does, yeah. Open up where it says search settings and make sure there's 3 asterisks there, like that. I'll just say it this way, because I don't wanna get too complicated here. If it shows an asterisk, that means what I just said. If it's named in my file, and it finds the exact same name in the other file, it's gonna say, okay, there's one, point to it. Or point to the one in the Class A stuff. If it's got the exact same name, right? You could get really fancy. Some companies try this, but it's almost too much organization. You could say, well, in the target file, anything that's got the letters I-N in front of it. And then in the source file, look for the same name, but it has O-U-T in front of it. It's a real organized way of making sure you're picking specific things, but we're just saying, if it's got the same name as what we pointed to before, point to it again, all right? So just put an asterisk in those 3. I'm not gonna explain any more than that. And then you basically say, all right, I'm gonna click on this little button, looking for the names. Actually, before I do it, no, I'll do it, I'm just gonna do it, okay? I'm gonna collapse some of these windows, because you know it worked if you come down here. I'll even collapse that one. I need more space on the screen because pixels. All those links in my inputs, they should all have green check marks, which means, yep, we found all of these in the source, in the outputs from the Class A. We found them all. They had the same name. That's what it should look like, right? It even says here, there you go. After you hit that button, they should all have green check marks. But they might not all work on yours, all right? I sometimes think maybe I should purposely make mine with a wrong name so it doesn't work. But I'll show you what to do about it. It does briefly mention it here. And if you get to this point and you can't remember what I'm saying right now, just ask me. But it says, if any links were not reconnected, you don't get a green check mark. It basically means that something wasn't named right. The name in the new one doesn't match the name in the old one. Okay, well, you can right click on it, and there's something called manually relink. And basically it's just like I did before. It says, well, what do you want to point to? And you physically would come out here and pick the new one, and it would repoint it, right? So I'm gonna hit OK. Let me just do this. Well, the next thing it basically says is, wait a minute, do that. Oh, well, it didn't. Yeah, I guess it didn't say to get rid of this yet. I could get rid of this right now, or I could do it in a couple steps. I'll do it. My instructions didn't tell me to do it yet, so I won't do it. But in the inputs, if I activate that, right, and I look at the one called body side main slab, now I just told you it found the new one, right? But look at it showing me. It's still showing that. Well, that's because it didn't automatically update the geometry. It updated the links. My input folder for my body side stuff, it does know, yeah, you're pointing at that one called body side main slab in the Class A stuff. But it didn't update the geometry yet because I had this button turned on, delay geometry. Remember we did that in the beginning. This is why we did it, so it doesn't automatically just update everything, okay? And if it doesn't automatically update everything, it's telling me, there's a part that needs to be updated in my assembly, inputs body side. Well, I'm in it right now, I'm in the inputs body side. So that needs to be updated. So all I'm saying is, when you turn on that delay, you have to update when you're ready to. And that might be nice, because there might be 10 or 15 parts that need to be updated by something you did. And you don't wanna update everything automatically, because sometimes you get errors and you're not sure where did that error happen, right? So it's better if you just say, all right, I made the change, let me update the parts that need to be updated. There is only one. You could actually update every part in the assembly, or even other assemblies that you got open in the session. I'm just gonna say, well, that's the only one, I'm gonna select it, update that part, let's see, before I do it. Update that part, and see now, the body side main slab here, let's see, okay. The body side main slab there, I don't know why it's yellow, but, I think I do know why it's yellow, but that's okay, it's yellow. It now points to the correct one, alright? So, that's why we did the delay geometry, okay? It does say delete now, so I don't need the outputs class A anymore. So I don't think you need the top of the tree to be active, but to get rid of a part from an assembly, it is simply right click and delete it. It doesn't really delete it from wherever you stored it. It just takes it out of this assembly, all right? Now just because it might happen to you, I can just sort of fake one in there. I could say, let's do this, let me do that geometry linker again, in case you don't get all the green check marks, okay? Let's say, I'm gonna say, well, the source now is my inputs, and the target is my outputs. I know they don't have anything in the target with a name, so if I hit that, I'm missing, hit that, search for matches. It should show me, why isn't it showing me, come on. What am I missing? I don't know why it's not showing me. I just did this on my own before, and I got, maybe I'll do it the other way around. Maybe it's because I'm doing it backwards. What did I say? I said, maybe I'll make this the source, this the target. There we go. Okay, so now I got a bunch that didn't work, all right? You might, when you do that part, you might get like 4 green check marks and 1 that isn't, right? What you would do is, it would be like, hey, it couldn't find the main slab. You can right click and go manually relink, and you just pick the slab, the correct one, right? That's how you fix it if it didn't work with the name, right? Does that make sense, kind of? Mine worked, so I had to pretend it didn't work. I went to another one. If you don't get all green check marks, click on the one that doesn't work, right click, do a manually relink, and look at the name of it and point to the one that it's supposed to be, and that'll link it up too. Okay? I mean, you could have even, in the inputs, you could have just went through these one at a time and double clicked on one, while you had the outputs of the Class A still here, and unselected what it was and picked the new one. All right, you could have done that. That's manually relinking too. All right, anyway, I think I beat that one for a while. So I got them all working, all right? And once you get rid of I took the outputs out of here again from the Class A, so my inputs doesn't see it anymore, so the links are broken again. But that's okay, I know they're pointing at the latest stuff, because I just updated everything. So yeah, it doesn't see them, but I know it's the latest. All right? Then it says, all right, hide the inputs. And I didn't have the body side active. I'm gonna activate the body side. Let me see, you know what? In my instructions, it says, make the body side work part, make the body side the work part. It's weird, because on my laptop, it behaved a little bit different. In my instructions, it says, note that the body side main slab feature references the large one. But it still doesn't. So this one did not update. Oh, you know what, I think I know why too. It's something to do, I said earlier. When I loaded the assembly, I didn't have the parts all fully loaded, right? So when I brought it in and I said update with the name there, and this one got updated, this part wasn't really loaded, or I should say, the body side wasn't really loaded. So it didn't think that it needed an update. Now that I've loaded the body side, I just made it the work part. If I go to Associativity Manager, now it says, hey, the body side needs an update too. It didn't know that a minute ago because I didn't have it fully loaded. And I don't know why it does this sometimes. It says, well, the inputs probably needs it too. Well, I know I did update that one, but because it's gonna say, well, if you update this, you probably should update that. What you can do is pick them both, or you can hit update assembly. Hit okay. So in this step right here, if you get to this step and it says, first note that the body side main slab features reference the large untrimmed surface. Yours might not. It might be like mine where it doesn't. If you remember, go to Associativity Manager and update everything. If you don't, call me over and I'll tell you. I'm gonna change my document now that I'm looking at it. Because it all depends on if the part was loaded. I'll say something like, if it does update it, great. If it doesn't, then do this step before you update, all right? Then it says, in this part, the body side, now we're gonna do the rest of the exercise where we actually build the shape that's gonna end up being like that. That's what our body side is gonna look like. Well, there's gonna be some holes in it next week that we put in. So we're gonna have our main slab with a pocket, kind of, and some fillets, some blends. Right? Seems like a pretty simple thing, but we're gonna use this procedure that it's kind of old school, but it's a neat way of coming up with the bend radius for a certain type of material thickness. All right. So let's see, I'm gonna go back to where it was. It says add some feature groups, right? Now, I don't know if you recall, but I put the feature group command on my home tab right there. If it's not there, remember menu, format, group, feature group, right? I'm gonna try to do this fast. I'm just gonna go to feature group. I gotta add some feature groups. One's gonna be called form. I'm gonna put it at the top level. So if I hit apply, it put it at the top level. It put it before input geometry. I'm gonna move them around because input's supposed to be first. You know what? It might be because that wasn't the work part. Okay. Well, if I update and move that up like this, so now that's the work part. So whatever I put in next will go after that one, I think. You can always move these, especially if there's nothing in. There's gonna be one called trim. I'll hit apply. Same level as form. Then I'm gonna make two more inside of trim. So let's see, I'll put it, the next one's gonna be fuel filler cutout. We're gonna use all these down the road here. Fuel filler cutout, but that's gonna be inside of trim. I'll hit apply. So there's a little plus there. Then there's gonna be another one called holes. Inside of trim. I'll hit apply there. Alright. Then there's gonna be one more called final at the top level. And because trim is bold right now, it should put it after that one. Yeah, and it did, so we'll put it after. So that's what it should look like. In the instructions, it shows you a little picture of that, right? Feature groups. I'm not dwelling on it because we're all experts, right? We're also gonna start working with the design of the actual feature we keep talking about, the body side. You know what I'm gonna do too? I'm gonna hide the, or I already did. It does tell you earlier, hide the inputs, because I don't wanna see that other stuff. All right, I'm in my working file, the body side. And we're gonna work with offset thicknesses and what material thicknesses. So we're gonna make an expression in the body side part. I am in the body side part. Okay. I'm gonna go to tools, expressions. Okay. We've done this before in my other classes. By default, I notice there aren't any expressions yet, only because the only data I've got in here is non-parametric stuff. It's all links. It doesn't have its own numbers. So there's no expressions yet. But we are gonna create one. There's gonna be a name. It's gonna be called body side material thickness. You notice I'm putting underscores. I mentioned this. I get caps lock stuff. But there are underscores. Remember that if you try typing in a name with spaces, it'll give you a syntax error. So I got body side material thickness. Let me show you the whole thing right there. The formula is just simply gonna be a number, 0.711, so not even a millimeter thick. Our metal's not even a millimeter thick. Okay, I'll just hit okay. In the tree, I have a user expression now called body side material thickness. So we're gonna use that quite a few times, okay? The construction geometry, all right? So we're making that thing I showed you at the end of the chat, at the end of the lesson, right? That shape with a pocket in it. But the data they gave us is on the outside, the Class A data, that's the thickness side. We're designing the other side for the whole thing. I know I can zoom in all day, there's no thickness to this, that's a sheet body, right? But the piece they gave us is outboard, I'll just say it that way. In this file, what's outboard, okay? It's in the negative Y direction. You know this little guy down here? I sort of bring this up in the instructions a little bit. Keep an eye on this guy, the view triad. Positive Y is pointing inboard. So negative Y coming outward. In this, the way I'm looking at it right now, to the left is negative Y, so that's outboard. If I look at it like this, now negative Y is to the right, right? So outboard is that way. But my pictures all show it kind of looking like this. So we're gonna design, not this side of material, but if there was a 0.71 mil thick slab here, a piece of metal, we're designing the side to the right, the inside, okay? So we're gonna do an offset. It says, well, let's see, it says hide the fuel door main slab, that's in here. Actually, do I have it? No, I don't have the fuel door main slab. I don't need it, but if I did have it, it would say to hide it. And then fuel door, cut line fuel door, this one. Yeah, so it's just, all I'm seeing now is the main slab, our center line fuel door, our center line of fuel door, and the cut line for the body side. And that is, remember well, let me show this, I'll remind you. That little cylinder inside there, we're not using that in this file. That's gonna be to make the actual door. That's gonna fit inside the opening. We're making the opening, which is this one. Okay, so I'm gonna hide the one that's just for the door. Technically, we really didn't need it linked in this file, but we got it. We just grabbed them all and brought them into our files. So there's the one we're gonna see, all right? Then it says, all right, you're designing the other side of material. So I'm gonna make a surface, where does it say to put it? I'm reading my instructions. Oh, activate the form feature group. So here's the form feature group, I'm gonna make it active. I thought I didn't put that in there, but now I see it. Okay, so to activate the form feature group, we're gonna do an offset surface of the body side main slab, which is the thickness side, it's not our design side. And we're gonna offset it, so I'm gonna go to the surface tab, here's offset surface, okay? You should always use body faces unless otherwise specified, that's the face rule. Pick that face, and it throws a 5 in there by default. Remember, a good habit is to reset these windows every time you go in, just in case you change something. I gotta pick it again now. It's at 5 by default. Instead of 5, I wanna use that material thickness, 0.711, okay? As a reminder, I know we've done this before, you could go to the expressions window here, the little pull down. It's called formula, okay? P2 is the surface offset I'm about to make, okay? Haven't made it yet, but I'm about to make it. Right now it's 5. I want it to point to this one, body side material thickness, right? Remember, there's a little trick to it to do it right. Make sure this is in edit mode like that, like it's blue. When that's blue and there's a cursor there blinking, then you come over here to the expression that you want and you double click. You gotta hit it just right. If I don't double click fast enough, it didn't get it. Okay, and see that went green again? It's kind of frustrating until you do it a few times. Make sure you double click, then it goes to it, okay? You can do it that way, and it plugs it in, see it's 0.711, and it knows that was it. Or, let me cancel that and do it again. Another way to do it, and once I show this, people start doing it this way more often. If you know the name of it, let me pick that face. If you know the name of it, just start typing it. The name of the expression. I know it's body side material thickness. As soon as I type in a B, well, there's only one thing in my whole part, one expression that starts with a B. It's right there. You can click on it, right? That's a faster way. Once you learn that one and get comfortable with it, you can do it that way faster. It's pointing to the same thing. Once I finish this, I think if I preview it too, it'll show the number there. Let me try it. I guess, yeah, there it is, once I previewed and undid it. Now it shows me the resulting value, can you see how it's gray? And there's an equal sign, that means it's linked, right? But it is actually creating an offset, it's tiny, but there's an offset right there. Okay, so I'm gonna hit okay. That's a new feature under form, called offset surface. We're gonna name that. We're gonna name that main slab design side, okay? In a rename. That's the side we're gonna be working with. Because what we were given by the Class A people, yeah, it's the right shape, it's the exact shape we need to use, but they gave us the thickness side. We need to design the design side, okay? Now, I'm naming that, and you might think, well, aren't you also gonna name the sheet body? Realistically, we probably would, but that's only for people that are gonna downstream, link to this downstream, but in our project, nobody's linking to it. If you do it, that's good, it's good practice, but I'm not gonna do it. So there's no need to rename the sheet body, in this case, okay? I'm also gonna hide the original one, the body side main slab. That way, this is the one we're gonna work with. So that finished part I showed you the picture of at the end of the Word document, it's gonna be that slab, which is the back side, the inside, all right? But the same thing is gonna happen here, okay? This is the opening. I like to diagram this really quickly. I don't get up and write stuff too often, but this is my exercise, you guys all. So, I'm gonna leave that there, because you guys can. So we've got, let me do this. This is what we were given. This is that main design side slab. And then here's this is where the opening's supposed to be. You know, on that cylinder would be like this, right? But I said we're designing the material thickness side like this. So what we're designing is offset, I know it's big, it's like 0.711 mils. It's actually gonna come around with a fillet like that. That's what we're designing, this, and same thing on the other side, right? So that's what I got showing right now, is this guy. But the thickness side is that way. So if you translate that this way, the thickness side is outward. Does that make sense? It's going to the right on the main slab and up and out from the cylinder. Kind of make sense? That's why we're doing that, all right? Whether you know it or not, it tells you what to do, but it does say, make a new offset of this guy's, offset surface, have it on body faces, pick that. Same thing, material thickness. Now, this is good and bad, but the extrude, or the offset and the extrude, that does the same thing. It remembers what I used last time, and it's linked to the same expression. In this case, that's good, right? If I didn't want it linked, if I was making some other extrude that I didn't want that number, I could reset the window, or you could, I don't know if you remember this, but make constant breaks the link, and then you could just type in what you want. But I do want it linked to the same thing, and if you hover over it, it tells you what it's linked to. That's the one I want. Just make sure it's going outward. Yep, it is. Okay? And that, kind of like we just did before, that's the fuel door opening design side. Okay? A lot of this is not really, you know, we're not showing you NX stuff, Jess. We're showing you a way of, this is kind of a method, a common method of designing, especially when we get to the bend. I'm talking and typing, you can't do that. See? Fuel door opening design stuff. Yeah, that's what I want. All right. And the same thing here, I'm gonna hide the one that's inside. That way, those are the two I'm gonna work with. I can still see the center line, all right? Fuel door. And then, I'll show you this. Now it says, all right, we just offset both of those. So we got the design side, that's what we're gonna be working on. Then it says, now offset what I just did, that cylinder I just made, offset that outward 3 times the thickness parameter. What? Offset that 3 times the thickness parameter, and we're gonna call it door opening center curve generating surface. Okay? Then it says, should say it, now do the same thing with the main slab, 3 times the material thickness. We're gonna call that main slab center curve generating surface. All right. I'll try to diagram this out. It's gonna be confusing. This is kind of an old school method of coming up with the right blend. Because what we're ultimately working on is, remember I said there's gonna be a pocket. And let me do this real fast. I don't like to bounce around too much, but see how there's a pocket here. okay? So, what I'm talking about, here's the slab, that's the slab we made, this is the design side. There's also a cylinder, there's not much of it, well, actually, we're gonna work with that, but it's inside. But there's a fillet right on the top where this main slab meets that cylindrical opening, right, that little fillet. Well, when they did this in the actual part, at Chrysler, or Stellantis, or what was it at the time, it was FCA, I think. They worked with their knowledge of sheet metal, which is really important. There's bend radiuses for certain types of sheet metal. So they know that for this type of metal, the bend radius, the fillet radius, where it comes across and then it goes down into the pocket, that should be no more or no less than 3 times the material thickness. All right. So that's why they're doing this, because they're using these rules. Because if you try to bend it smaller than that, it'll wrinkle or it'll tear or something. So they're doing this little method here. It's gonna seem odd as you do it. When it's all said and done, maybe you'll see exactly why, but it's just because it's important to make sure you know you're following the rules about the bend radius, right? So it's gotta be 3 times the material thickness. So, all right, so go ahead, let me do what I was gonna do and see if it makes sense now that I said that. Let's see, where was I at? I made that cylinder. Yeah, now it says take the main slab design side. No, it doesn't, it says fuel door opening design side. So this guy, it says offset it outward 3 times the material thickness. All right, another offset. I'm doing all this in the form group, by the way. Offset that outward, but this time it's not just the material thickness, it's 3 times the material thickness. So I'm gonna go to equals, go to formula, and it's already got the material thickness, but how do you do 3 times? You can do an asterisk and a 3. I hit enter and it's 2.133, it's still not much, it's still 2 mils, but it's coming out a little more than 2 mils, okay? But we're gonna name that. And again, the nice thing is we don't have to worry about the sheet by name. So that is gonna be door opening. Opening. Center curve. Generating surface. I'm using the names that I was given, so. Generation. All right. Most embarrassing watching me type. Door opening, center curve generation. What? Okay, we'll see. We'll get there. Now that I've done that, I'm gonna hide that other one. So all I've got is that 3 times material thickness offset. And then we're gonna do the same thing with this guy. Okay, you say so. So we're gonna go to offset surface, take the main slab design side, this guy. And again, it still has that formula typed in, which is very handy. It's already there. I don't even have to worry about it. It's going to the right. Of course, I got to name it. I should have, let me do this. If you go to rename, and you can copy this, Control C. You want to go to this one, do a Control V, but this is the main slab center curve generating surface. So I just got to change this. Didn't really save much time to do that. Anyway, so we got these 2 surfaces that are offset 3 times, and again, it went back 3 times, inboard. Try to zoom in the right way. That's the new one I just made, so I'm gonna hide this one. Okay. Now here's where we're gonna work with that bend radius thing, right? We're actually gonna make a tube that has that radius, right? 3 times the material thickness. So we're gonna make a tube around where these 2 meet, right? Bear with me. It doesn't seem like it makes a lot of sense right now. We're doing an intersection curve, okay? Between that generating curve surface slab and the door opening slab, hit okay. I made an intersection curve. Guess what we're naming that too? Center curve. Fuel door opening. It'll all come together in the end, right? I know you're going, wow, I'm not You won't remember all these steps, but I hope, hopefully you get an idea of a methodology here. Then it says, hide all the surface geometry. I'll just grab those two and I don't move my cursor too far, I got that. So there's that intersection. There's our center line we've been looking at all along. That's the right one. Doesn't look very dark in that screen. Now we're gonna make a tube. The tube command is, it's in a couple different places. I tell you to go to the surface tab, go to the more button here. And I have it at the top because I used it recently, but it's right there. It's in the sweep group, okay? Now this one too, you're gonna go, what? It says, use the formula to do it. The outer diameter has 6 times the material thickness. So anyway, there's the curve. What is that? There's the feature curves. You don't have to do it. There's the curve. And then we're gonna put a formula in there, the outer diameter, but it says 6 times now. Well, those 2 surfaces I made were 3 times. What's going on? Well, the surfaces, well, when we make the blend, fillets, blends, they use radius. This guy, look what it's using, it's diameter. All right, so the diameter, is twice the radius in a circle. Hopefully you know that, right? So we don't want it to be, 6 times the diameter is the same thing as 3 times the radius, if that makes sense, all right? So, formula here, gonna be body side material thickness, asterisk 6, which should be 4.2 something or other, 4.266, all right? Okay. Oh, no, don't do that. Let me edit that. It's a tube, but see how mine looked like it was segmented? I forgot. I show you a picture of the settings. For the Boolean, set it to none. For the settings down here, don't do multiple segments, do single segment. Without going into great detail, multiple segments more closely matches the curve, but it's not as smooth. It has a bunch of internal boundaries. Single segment, it's smoother. It just doesn't have internal boundaries. It may not as close. I mean, it's very precise still, but it's a little bit less precise than multiple segments. But it's a lot easier to work with if it's all one smooth segment. All right, so you're gonna have a single segment. All right, so I got that. That's supposed to be where the fillet would be. So let me show, you don't do this in the instructions though, but if I go to design side, the main slab, and design side of the fuel door opening, see, if we were to blend those together, that tube is supposed to be where that blend is. It's right where they blend together, right there. If there was a fillet where these two meet, that tube would be sitting right in, would be nested right in that fillet. But we're kind of working the opposite way. We're working with the radius first, and then building our wall from there. And even that might not have made sense to you, but it'll make a little more sense as we go. We are gonna do something called an isocline curve, like a reflect line. If you use a complete circular tube, basically we're gonna say, where does the direction of the surface match this, right? And it would be right at the top and right at the bottom. Maybe I'm gonna show this too. This isocline thing. Yeah, this is my only exercise. So we're doing this. We got a tube there, and if I look at the tube like this, a section through it, there's a center line going through that. Okay, so that's a donut that's going around like this, so I got a section line. So I want to find on this surface, where does the direction of the surface match this? Okay, so if I move this up, it's right there, right? If this is at an angle, so that would be 0 degrees. That would be, that would be 90 degrees, right? 90 degrees to the line. Where does it match this surface at 0 degrees? Where is it the same direction as this line? It would be right there. Okay. That would be 45 degrees. Of course, so that would be 90 degrees to that line. Of course, 0 degrees is there, but it's also there. All right, and that gives us an issue. If I try to make an isocline at parallel to that line, it's going to say, well, you got a curve there and a curve there. All right, so I only want one side of it. I don't know if that makes sense. So what we do to avoid the isocline curve being on both sides of that donut is we slice that donut in half with the generating curved surface we made, the door opening generating curved surface, this one? Cause that's where the curve, we made the curve with that guy, so it's slicing right through the middle of it, see that? So we're gonna chop off the outside of that tube. We're gonna do a trim body, go to home tab, trim body's right there. I'm gonna trim this, now I got it on, well, single body that works, that is all one body. I wanna trim it with that, okay, now there's two sides. The arrow points to the side that's going away, and I tried to show it in here. Some people have a hard time visualizing it, but it does say, keep the inner half of the tube. Think of it as the inside of the donut. I don't know if you can tell from that picture or not, but I want you to keep the inside, get rid of the outside. And mine went the correct way by default. See, if it was the other way, now it's keeping the outside and chopping off the inside, see that? But I wanna keep the inside, so it should look like that. I'll hit okay. I'll hide this again, we don't need that anymore, I just need that to trim. I'll hide the intersection curve, I don't need that anymore. But now I've got, you know, if you think of my picture up there, now it's not a circle anymore, now it's a crescent shape sort of. So only on the bottom will it say it's 0 degrees to that line. Right? So then we're gonna make that line. If you worked in other CAD systems, it might have been called a reflect line or something like that. If you go to curve, it's in the more, under derived curves, under more, it's called isocline. And it's kind of a complicated looking window, but the face I want to measure is, it's on tangent faces. I don't want to measure this flat face, I'm going to ignore it. I'm going to pick that. It could have been single face because it is all one face on the inside. Now, again, imagine if it was a complete donut, a complete tube, it would have went all the way around like that. But I don't want it all the way around. So there's the face. What's the direction you want to measure it to? Our old friend, the center line of fuel door opening. Okay, it's at 0 degrees by default. We do want it associative, by the way. It's at 0 degrees by default. Well, if I looked at it up here, it's right at the bottom of the circle. Like I said, if you move that line, where is it going across straight? Right at the bottom. Kind of hard to see that. So 0 degrees is where does it hit the surface in the same direction? Okay. Now here's the tricky part of this too. Depends on which way your arrow's going. It says we want it at 5 degrees. I think that's what I said. Yeah, 5 degree angle. See, I'm trying to show it to you here. And it says slightly to the negative Y side of the face. So let's try 5 degrees. And I should have actually, let me zoom in down here. I'll look at the bottom because my picture kind of shows the bottom. I'll take the display. Let's make it 0 for a second. So it's right in the middle of this half tube. If I make it 5, watch when I hit enter. I'm gonna hit enter right now. See how it went a little bit to the left? Okay, so the line is actually tilting kind of like this. It's a little bit to the outside. In my picture, I'm telling you slightly to the Y side. So when it was at 0, it was right down the middle of this. When I hit 5, it went to our left. And you see how I show a picture of the view triad? So that's why when it says negative Y, you're like, which way is negative Y? Look at this guy. Watch, if I make it negative 5, it'll go the other way. I think it'll let me do a negative. Oh, I did negative 55. See, it's kind of hard to tell. That's negative 5, that's to the right. It's really hard to tell, but if I make it a 5, see how I went to the left, in the negative Y direction? So if you're not sure, play with the number a little bit. Try 0, try 5, try negative 5. It should be going to the left if you've got the Y pointing to the right. Right, and you're going, really, is that important? It kind of is. Okay. I'm actually getting towards the end now. That stuff was about the hardest part of it. Okay, so why did we do all that? Here's that old school methodology of coming up with where the wall should be. So, I did make this guy called fuel door opening design side, that one. But actually, that's not really it, because it's a pocket. It actually has to get smaller as it goes into the pocket. So a cylinder won't work, right? Because if you stamp the part with an exactly cylindrical pocket, it will either tear or it'll lock it up. Right? When you stamp it apart, it's got to open up. It's got to be an open angle when you stamp it. So like we're stamping it. Let me show them. Nice slab there.
we're gonna stamp it from this side, stamp it and pull the die back, right? So it's gotta be bigger in this orientation. Instead of a cylinder there, it's really gonna be a cone. It's gonna be bigger on this side, smaller on that side, because the bottom of the pocket's gonna be this side, okay? So we're not gonna use that cylinder. We used it to come up with where this, the reason we made that cylinder, actually I just showed it the wrong thing, was to come up with this guy, to come up with that curve, right there, that little curve. Okay, that curve, we're gonna use it to make, I'm gonna call it a cone, but we're not using any kind of cone functionality. Okay, we're gonna make a law extension. I don't know if anybody remembers law extension, I did that in my other NX classes. A law extension is like sweeping a straight line along a guide at some angle, okay? The guide is gonna be that little 5-degree outward isocline curve. It's not exactly at the center of this half tube. There's a lot of words there. So that's the curve, I'm gonna pick that guide, okay? We're gonna do it with respect to a face, because there's an angle to it. I want it to be tangent to this face, meaning 0 degrees to the face. I want the same direction as the face. Well, it just so happens, right where that curve is, that's where I want this law extension to brush against that face, at 0 degrees. So if I pick as the face, and I don't wanna pick body faces, because that'll pick the outside of it, I'll do tangent faces there. Did I tell you that? Oh, I say use single face, tangent is one too. So pick the inside of the tube. Alright, it's making a, I gotta give it, right now it's at 90 degrees. What is it doing? Let me see if I can tell you what it's doing. See that surface? It's actually coming out from the tube 90 degrees, like perpendicular. Right at that curve, it's coming out. That's not what I want. That's not a nice cone shape. We're gonna make it 0 degrees. When I make it 0 degrees, it is 0 degrees at that curve. That curve is at the 5-degree location from the center. So the angle of that sweep is what we want for the actual opening of our pocket, okay? Now, the pockets, and again, keep looking at this view triad. The bottom of the pocket's in the positive Y direction, so this is outboard of the vehicle. The pocket's over here on this side. Well, I need more surface, that's not enough. Just by default, it was 10 mils in one length, and then the other side, which should be actually asymmetric, so we can give it 2 numbers. I tell you to come out 30. 30 in one direction and 10 in the other. Actually, most of it needs to come out this way. So you can use the numbers the way you want. If I do 30 there and then 10 down here, see, most of it's coming out this way. I want most of it to come out that way. So you could experiment with flipping the arrows here, or you could simply say, well, let's just do 10 this way and 30 that way. When it's all said and done, there's a picture of it. There's our Y direction. Can you tell by that picture? It's getting smaller as you go to the right. Can you sort of see that? I don't know if you can. And then you can see, well, then most of the surface is going that way. A little bit's going this way. The wider end is coming out just a little. The narrow end is going in a lot longer to the right. So, and that's it right there. Again, right? So I got it. If you're having a problem with that, I'll help you. And after all that, that's why we did all that 6 times and 3 times and making a tube and all that, just to make that surface. That surface is gonna, it's gonna be in a position so that when we do the blend, it's gonna be right there where the material thickness told us the blend should be. I'm gonna hide that. I think I can hide these things, like that. All right, and now we've got a law extension. We haven't named a few, or did I? I might not have named things. I didn't tell you to name the isocline. Oh yeah, I did. Oh, center line of fuel door opening. Well, I'm making you do it, so I'll do it. Center line of fuel door opening. I'll change the name. I know what I mean by that, right? And then the law extension that we just made is actually the fuel door opening surface. So that's, it is our design side, and it's the real one we're gonna use. When said I'm right. Okay. Now, the next couple steps, I'm gonna do these really fast because they're kind of basic stuff too. We need to make the bottom of the pocket. It's gonna be flat, okay? So basically, I'm gonna set it up with a plane back here where we know the depth the bottom of the pocket's supposed to be, and this information we just have, all right? So we're gonna put a plane, and the plane is gonna be perpendicular to the center line, because remember, that center line, we actually made it in one of the first sessions, very first session we had an assignment. We made it from our own circle that we made a long time ago, and remember how I said everybody's circle is gonna be a little different, because you pick 3 points on that opening, and nobody picks in exactly the same spot. So everybody's center line is probably in a slightly different spot. We wanna make sure in our parts, the back of the pocket is perpendicular to that center line, because everything's driven kind of by that center line. So we're gonna make a plane. When you make a plane on a curve perpendicular to it, you usually run it through a point, okay? Well, I'm gonna first make a point where the design side, main slab design side, intersects, basically, the plane is gonna be 15 mils from where this slab is. So the bottom of the pocket, and again, this is just, we got this information from wherever. The bottom of the pocket, the flat bottom, is 15 mils from where this surface is, okay? So I'm gonna start out by making an intersection point. I'll go to the home tab, actually I'll go to the curve tab, here's point. I can do an intersection, project intersection point. Okay, now remember when you're doing an intersection point with curves, the second thing you pick has to be a curve, right? I know I'm gonna pick this line and that surface, but I don't wanna pick the line first, because the second thing has to be a curve. You learn that the hard way, right? So the first thing I'll pick is that slab, second thing I'll pick is that curve, and I just made a point. It's kinda hard to see it, I'll hide the slab again. There's my point right there. That's where the slab is. The bottom of the pocket's over there, 15 mils. How do we know? Because that's what I'm telling you. So we go to point again, point along curve, point on curve edge, okay? Where do you wanna start it from? The start of the curve? No, that's way out here, way out there. That's not a precise location. We're gonna say, no, we're gonna give it a start point. I didn't pick the curve yet. The curve is our center line. The start point is the one I just made, and I wanna make sure I pick that. Okay, I'll wait for the 3 dots. It almost looks like it's not letting me pick it. Go back there. There it is. Sometimes it's weird. If it doesn't let you pick it, wait for the 3 dots. Pick it from the tree. You can't go wrong that way. And then the curved length is 15. And make sure it's going towards the smaller side of the cone in the positive Y direction, 15 mils. Okay, what is that for? That's where our bottom of our pocket's gonna be. We're gonna put a plane there. Plane. Come on, on curve, there it is. A plane on curve. What's the curve? That's a curve. By default, it's normal to it, that's fine, but where do you want it? On the curve. Through a point. This will be the point to the back, right there. Okay. So that plane kind of represents the bottom of our pocket, okay? But we're gonna make a surface there. This one's a little bit tricky, I guess. I said this is all basic stuff, but this is something slightly not basic, I guess I'll say. I'm gonna make 2 lines, like a giant plus right here, and I'm gonna make a sweep along guide. I'm gonna make a line like this and sweep it along a guide like that. But I want it to be the same direction as that plane. That plane is not 100% in X, Y, or Z. It's tilted because it's on this line, which we all drew, whatever we drew it. So it's not exactly lined up with an X, Y, and Z. Well, you can make a line that is associated to Y and Z. You know, Z is this way, Y is that way. If I look at it from the front, I'm sorry, X and Z. This is X, that's Z. Well, I want to make lines that are parallel to X and Z, but on that plane. So one way to do it is, I shouldn't have hit that point, sorry. I hit the second point. I want to make a line, starting at that point, but I'm going to say in the, which one do I do first? Along X. So that's lined up with X, okay? Actual X, absolute X. But that's not necessarily on the plane, because the plane's tilted a bit. So you can say, support plane. I don't wanna use automatic plane, I wanna pick my own plane, select plane. And if you watch that line right there, I'm gonna pick this, watch that line. So I picked that plane and it shifted a little bit. So it's parallel to X, but it's projected onto my plane. And then I want it to go, because I'm making a surface that's big enough for the back of the pocket, it says, make the distance, started at -150. And end it at, oh, I got it the other way around, 150 like that, okay? There's one line, and then I'm gonna do exactly the same thing, but in the Z direction. Okay. So start at this point. This one's gonna go along ZC, Z direction, but on a plane, on my plane. Pick that plane, purple plane. Okay, and then the same thing here, -150. I don't know why it always defaults to something like 2,704. So there's those two lines. Why did I make those two lines? They're right on that plane. I can use them to make a nice flat surface. We're gonna go to surface, we're gonna go to more, we're gonna go to sweep along guide. And technically, it doesn't matter which one I sweep along the other, but I tell you to use, X is the section, so that's this one. So I'm gonna sweep this one along that guide, which would really be the same thing as if I swept this one along that guide. So sweep that one along this guide, okay? And I don't remember, I tell you to use 130, -130 and 130. Again, it's really just gotta be big enough to go beyond where the wall would be. Oops, and I've got it on solid. I don't wanna make a solid, I wanna make a sheet. Can I perform offset operation for sweep? Oh, I see what I'm doing, never mind, you know what? I was in the wrong field. Oh, I'm definitely in the wrong field, you know, we're not doing a sweep along guide. I think I used to do a sweep along guide, but I'm not, now I'm doing an extrude, sorry about that. I'm looking at my instructions and I'm looking right at it, and it says extrude, and I did a sweep along guide. There, see, sorry. So, when you do an extrude, and this could be also what I said. I could extrude this along that, or I could extrude this along that, either way. But it does say extrude the X in the direction of the Z, and then it says for the values, make it -130. Yeah, I was trying to do an offset of a solid. But here too, it does say make a solid. I tell you, even though it's gonna be a sheet, because it's an open profile, I'm taking an open profile. And we don't wanna do any boolean, that should be none. It will make a sheet, right? Remember in extrude, it'll make a sheet if it's an open profile. But you should, as a best practice, if you know what you want it to be a sheet, set it to sheet. Just in case something ever changes, and, did I get the right line? Yeah, I might have made that line too long, but it doesn't matter. As long as it's more than big enough. But sometimes if you make something, it shows up as a sheet, and then you change the profile, and it might close on itself, and then it turns into a solid if that was set to solid. So you don't wanna do that. Anyway, so that's the bottom of the pocket. We're calling it the hinge mounting surface. We're gonna make holes in it later. We're not gonna really mount a hinge to it, but that's where the hinge would go. When you open up the door of a fuel door on a vehicle, there's a hinge in there, right? That the hinge is on. And that's what we're setting up. That's where it would be. So that's a hinge mounting surface. Now, I got two more steps, just a couple of fillets, all right? So it says create a face blend between, here's face blend, I'm still in surface tab, here's the face blend. Between the fuel door opening surface. So I'm starting my pocket, which is the fuel door opening. I'm starting it by taking that cone that we made and the back wall and putting them together first. Now we're making this radius just more than big enough. Remember, on this type of metal, it should be no smaller than 3 times the material thickness, right? And we're gonna make sure we're way above that. We're gonna say, blend this guy to the back wall at 6 mils, 6 mil radius, okay? And it's gonna, you'll see what I'm doing. It's gonna go negative Y on that slab, inward on the surface. I'll just hit okay. So there is our fuel filler formed surface, that's the fuel filler itself, before I attach it to the main shape. So of course I have to name it. One more step, fuel filler formed surface. Now I've got our design side main slab. Right there. Okay. And where they meet, again, we wanted to make sure it's the right radius for our material thickness, which is 3 times the material thickness, right? So, what is it, face blend? And I'm gonna start with this because I've been working with this thing. Start with that. Now this one's gonna blend, you know, where the main slab goes inside the pocket like this. Right, so it's actually here, if I look at it from behind, the blend, kinda hard to show you this, the blend's gonna be out here like this. I'm on the back side of the main slab. So that means it's coming out of that cylindrical shape, so it's gotta go outward. And then I'm gonna pick the main slab face. That one's already going the right way. You can see it's sort of previewing it right there and there. That's where we want it. But it needs to be, not 6, it needs to be. And I could do it here. I could double click on body material thickness or body side material thickness times 3. Or, just to remind you, I could come down here and I could start typing in B, body side material thickness. And even right in this window, you can do it times 3. Okay. And hit OK. And that is our body side. Well, that's the main chunk of the body side. What we got left on the body side is to put the holes in, where the fuel filler goes in, and then where the 2 little screws are to put the hinge on there. All right, so we're gonna do that next week. And of course, that's called final form before trim. You guys are all like, come on, I wanna go. And I'm typing fat finger. Final form before trim, all right? That's pretty much it. I wanna save everything. Just wanna make the assembly work part. Save that, which saves this work part and everything in it that needs to be saved, okay? And not that this is something you need to do, but if I show the, tube, trim body, show that. Again, it should be sitting right there. It's nested right where the fillet is. So we kind of worked backwards. We started with something that represented the material thickness, knowing that it had to be 3 times the fillet had to be 3 times the material thickness. So we kind of worked from there and then went back to figure out where our fillet's supposed to go. Anyway, and all that's left of that cone-shaped surface is that cone-shaped surface I made. Most of it got trimmed out because of the fillets. That's all that's left, but it's in exactly the right spot based on where the bend should be. All right, any questions? Okay. Everything was real crystal clear and crisp in your mind, and you know exactly what we're doing every step, right? I don't even know why we're doing it sometimes. Question? Oh, you want my